properties, and it will be you will be able to do the questions very quickly if you know the properties or if you know the results. Okay, so the first one, what they are saying, x and y coordinates of point of intersection of tangent is the geometric mean and the arithmetic mean of x and y coordinate of point of contact. Okay, so let's consider a parabola. Like, let this be a parabola. Just a minute. Okay, let this be one of the tangent. Okay, and let this be another tangent. This be point A and this be point B. Okay, let this point be a t1 square comma 2a t1. Okay, so this tangent will be what? t1x is equal to, t1y is equal to x plus a t1 square, right? And similarly, if this point is a t2 square comma 2a t2, okay, this tangent will be what? t2y is equal to x plus a t2 square. Okay, obviously the parabola we are considering is y square equal to 4ax. Then this point of intersection P, we have derived this in previous video. It was what? a t1 t2 comma a t1 plus t2, right? So what is the x coordinate? If you notice, the x coordinate is geometric mean of the x coordinate of point of contact A and B, right? If you do calculate geometric mean of x coordinate of A and B, you will be getting this point, right? This is the geometric mean. Okay, and the y coordinate, right, is the arithmetic mean. 2a t1 plus 2a t2 upon 2 is the arithmetic mean of the y coordinate of the point of contact. Okay, so this is the first property. Okay, it is very, very useful, so remember this. Okay, and in this way it is very easier to remember the point of contact also, right? P is what? a t1 t2 geometric, that is geometric mean, comma a t1 plus t2, that is arithmetic mean of the y coordinate and x coordinate. Okay, second property, what is this? Locus of foot of the perpendicular from focus upon any tangent is tangent at vertex. Okay, again let's consider a parabola. Okay, consider tangent on this parabola. Okay, let's consider tangent on this parabola. Let this tangent be what? ty is equal to x plus at square. Okay, and this be the tangent at vertex. Okay, this line is what? Tangent at vertex. Okay, let this point be S. So obviously this point will be what? at square comma 2at, right? Let this point be P. Okay, point of intersection of this tangent at y-axis. Okay, which is also the tangent at vertex. Okay, so if it is y-axis, definitely its x coordinate is going to be 0, right? If I put x equal to 0 in this, y will be how much? 80, right? Y will be how much? 80. Okay, now and let's consider focus. Okay, let's name the focus as S and this point be Q. Okay, this point be Q. Okay, so let this be a comma 0. Okay, so what is the slope of SP? If I calculate slope of SP by 2-point form, I'll get 80 minus 0 upon 0 minus a, right? That is what? 80 upon minus a. So a and a cancel, you will get minus t, right? And we already know slope of tangent m is equal to 1 upon t, right? That is slope of PQ. So m into SP into m into PQ will be equal to 1 upon t into minus t, which will be minus 1, right? It means what? That SP is perpendicular to PQ. Okay, so this is perpendicular, right? So this statement holds true. right? What is that? Locus of foot of perpendicular from this focus, right? Foot of perpendicular from upon any tangent, right? This is a random tangent because we consider this point to be a parametric coordinate, so it can be any point, is tangent at vertex. That will be coming to be what? Y-axis. Okay, this is the second property. Third one, I think we have already seen this. Tangent at extremities of focal chord are perpendicular and intersect on directrix. Okay, right? Let this be the parabola. Okay, this be the directrix. Sorry, this be the directrix, which is x is equal to minus a. Okay, and let this be the focal chord. If it is parameter, this point is PT1 and this point is QT2, right? Since it is a focal chord, it is passing through S, that is a comma 0, right? And we know that T1 T2 is equal to minus 1, right? Okay, what about the tangents? What about the tangent at this focal chord, right? Endpoints of focal chord, they will be having the point of intersection, right? Let this be equal to R, right? So we know the now only we have seen it is geometric mean of x coordinate and arithmetic mean of y coordinate, that is a t1 t2 comma a t1 plus t2, right? And since it is a focal chord, t1 t2 is equal to minus 1, so I can say R is minus a comma a t1 plus t2, right? So R is definitely going to be lie on directrix, right? So this property is proven. Tangent at extremities of focal chord are perpendicular, and locus of perpendicular tangent is what? Directrix. So they are perpendicular and also they are intersecting on directrix, right? We have proven this before, that the locus of point of intersection of perpendicular tangent is what? Directrix, and this tangent's point of intersection is also lying on directrix, which are the tangents sketched at the end points of focal chord, right? So this is proven. Okay, this is the third property. Now let's do some questions based on these properties. What are they saying? Tangents PA and PB are drawn from the point P on the directrix of the parabola. Right, now this is a parabola. Right, now this is obviously not a standard parabola or shifted parabola, just as it is. Right, this is written in the form of SP square is equal to PM square. If you remember the definition, right, what was that? SP square is equal to PM square. So if I consider this is a directrix, right, and this as a point S, and let it be any random point, SP is equal to PM. That is the definition, right? How I came to know about this? Because this 169 is nothing but written as 5 square plus 12 square, 13 square, right? So this is in the form of distance formula is equal to distance from any particular line AX plus BY plus C. Okay, so this line equation will be what? 5x minus 12y plus 13, right? And this S will be what? 2 comma 3. By comparing it with x minus x1 का whole square plus y minus y1 का whole square is equal to lx plus my plus n upon l square plus m square, right? This is the basic definition of parabola, what we have seen in the first video, I think. Okay, now what do they want? They want find the least value of the radius of circumcircle of triangle PAB. Okay, so let there be a parabola like this. Okay, are drawn from the point P on the direct tangents PA and PB. Now there will be any point, not consider this point to be P, right? Otherwise it will create a confusion. According to them, P is some different point of intersection, right, of tangents. Okay, find the least value of the circumcircle of triangle PAB. Now these are the end point is PA and PB. Sorry, this is PA and PB. Okay, and we want to find out the least value of the radius of circumcircle of triangle PAB. Okay, so if this is a chord, right? The least value of the length of the chord is how much? It is equal to lattice rectum, right? That we have seen in before videos. Okay, and if it is a lattice rectum, it means has to be a focal chord. If it is a focal chord, it means it will be making an anti-degree. That's why it will be making a circle. Okay, for which, okay, this circle will be passing through A and B and having it as a diameter, right? Like this. Okay. Yeah. So if it is the least value, right? Because the least possible length of any chord is the focal chord. Okay. And that not only any focal chord, it is a focal chord which is perpendicular to the axis, which means it is a lattice rectum. So this length is lattice rectum, right? Then they want the least value of radius. Now, if it is a lattice rectum and this is 90 degree, it means it is a diameter of this circle, right? So we want radius. Radius will be equal to half of diameter, right? And diameter is nothing but lattice rectum. Okay, diameter. So basically, we have to find the lattice rectum of this parabola. Okay, so if we know that lattice rectum length, right, it is equal to double of the distance of focus, right? Focus from the directrix, right? This is a directrix, because this is A and this is also A, so we can say this is 2A, right? For a normal parabola, obviously, but this result will be holding true for the other parabolas also, right? 2A is half of the whole length of lattice rectum, right? So 2A is a distance of focus from this line. So basically we have to find radius will be how much? Radius will be nothing but 2A. It is the half of lattice rectum. Okay, and that is distance of 2,3. That is focus from directrix. Okay, 2,3 from directrix. That is what? 5x minus 12y plus 13. ओके, सो अब इसका डिस्टेंस कैसे निकालेंगे हम लोग? मॉड ऑफ ax1 प्लस by1 प्लस c अपॉन अंडर रूट ऑफ a स्क्वायर प्लस b स्क्वायर, राइट? सो अगर मैंने अप्लाई किया तो क्या आ जाएगा? 5 इंटू 2 माइनस 12 इंटू 3 प्लस 13 अपॉन 5 स्क्वायर प्लस 12 स्क्वायर. ओके, तो 10 प्लस 23 माइनस 36. Yeah, so that will be how much? 13 only. 13 upon 13 is 1. Okay, so ये आ जाएगा minus 13 upon 13, है ना? या उसका मॉड निकालेंगे तो कितना आ जाएगा? 1. So that is the length of the least value of the radius. Okay, so this is a question based on the property of the parabola. Okay, let's see one more question. What it is saying: tangents are drawn to the parabola. Again, it is a similar kind of question. At the extremities of the chord. Now this is a chord. Okay, they have given it as a chord. Earlier they didn't specify any chord. They just said that they want it to be the least value, right? That's why it is a lattice rectum. Now find the angle between the tangents. Okay, so let's first assume the parabola. Okay, and this is a chord of that parabola, 2x minus 3y. So I'll consider this to be what? 2x minus 3y minus 18 equal to 0, right? And what will be the focus? The focus will be on this here. It will be 3 comma minus 4, right? Now we have to see whether this focus is lying on this chord or not, because if it is lying on this chord, then it means it is a focal chord, right? Okay, so let's see whether 3 comma minus 4 is lying on this focal chord, is this chord or not. Okay, so अगर मैंने इसमें रखा तो मुझे क्या आ जाएगा? 6 minus 3, इंटू -4 -18, है ना, 0 हो रहा है ये। तो इसका मतलब क्या है, ये फोकस है, तो ये जो है ये फोकस से ही पास होगा। ओके, और अगर ये फोकस से पास होगा ये कॉर्ड ए बी, तो इसका मतलब ये क्या है, ये फोकल कॉर्ड है ना। और अगर ये फोकल कॉर्ड है तो वी नो द पॉइंट ऑफ इंटरसेक्शन ऑफ टेंजेंट एट द एंड पॉइंट्स ऑफ फोकल कॉर्ड is on directrix and they are perpendicular, right? So the angle between them will be how much? Directly 90 degree, right? So this is the type of questions what you can expect on the properties of tangents of the parabola. Okay,